Hello, today we're going to look at what is a function. So a function is a relation. Now if you remember the word relation, the relation simply means a group of ordered pairs that you're going to graph on a graph. So a function is when you graph a group of ordered pairs and each input has exactly one output. Now input is the x, or the domain. There's different words for the, you have an ordered pair. The first number is the x, or the input, and the second number is the y, or the output. So every input has exactly one output. What that means is the x value, or the domain, those two words are synonymous with one another, x and domain, cannot repeat itself. So if you have a group of ordered pairs, you look at the x values and make sure that it never repeats. The y value is called the range. Each output, which means each y, does not necessarily have only one input. That means the y can repeat, the x cannot. So let's see what that looks like when we have a mapping diagram. This is a mapping diagram. And what we do is to read this is you start here with the first number and look to see where the arrow is drawn. Notice that this one up here says x, so this is your domain, or your x values. This one's your y, or your range values. So these create ordered pairs. The first number from the first mapping diagram over here is your first number of your ordered pair, and the number over here is the second number of your ordered pair. So if you follow the lines, -1 to 2, our first ordered pair is -1 to 2. And let's just graph that and see what that would look like. Our second one is 0 to 2. If we graph that, this is what it looks like. 1 to -3 is our second ordered pair. There's where that is. 2 to -2. And then we have the last one, which is 8 to 3. So that's how you read a mapping diagram. You start with the number over here, follow the line, and that shows you the ordered pair. So here are the 5 ordered pairs that are shown from this mapping diagram. If you look down here, remember a function, the x cannot repeat. So let's look at the x values. We have a -1, a 0, 1, 2, and 8. None of them repeat. So that is the definition of a function. So this would be a function because the x does not repeat. If you look up here visually on the graph, you can tell whether the x repeats. This is the x-axis. Okay, so look here. Here, if you thought what this ordered pair was, this ordered pair was -1, 2, and so forth. You never have 2 points on one vertical line. If you had 2 points on one vertical line like this would be the x repeating, but we don't have that. So this is a function because the x does not repeat. So you ask yourself, does the x repeat? No. Is it a function? Yes. So a no becomes a yes. It's confusing, but we don't want the x to repeat. If we look at this mapping diagram, with the first one we have -2, -1. The second one is 3, 0. I'm just writing the order pairs and showing you how to graph them. Now look here at 4. Notice that there's 3 different lines coming from it. So the first one is 4, 0. The next one is 4, 2. Then we have 4, 4. And then we have 10, 6. So the question is this a function? If it is a function, the x does not repeat. But look right here. We have in the ordered pairs, the first number is the x. We have a 4, a 4, and a 4. There are 3 times that the 4 repeats. If you look up here on the graph, you'll see that you have 3 points on one vertical line. So, does the x repeat? Yes. So is it a function? No, not a function because the x repeats. Here's another mapping diagram. So if we were to write the ordered pairs, we have 0, 5. We have 1, 5. We have 2, 5. And we have 3, 5. Does the x ever repeat? Look at the x values here, 0, 1, 2, 3. X does not repeat, so is it a function? Yes, it is a function. Okay, look at this one. We have the ordered pairs. -3, -1, -3, 0, -3, 1, -3, 2. Does the X repeat? It repeats every single time. So is it a function? No. The X cannot repeat. Here we have the ordered pair -2, 3. But then we have -2, 4. I can stop right there. What happened here? You see that the X value, or the domain, repeated. So is this a function? No. The X cannot repeat for it to be a function. We can look at these group of ordered pairs. These are relations. A relation is a group of ordered pairs. So in this relation or group of ordered pairs, all you have to do is look at the X value. We have a 0, 1, 2, 3. Does the X repeat? No. So is it a function? Yes. Second group, look at the X values. We have 0, 1, 2, and 3 again. Does the X repeat? No. So is it a function? Yes. In the next group, we have -2, 2, and 2. Right here, we see that the 2 repeats. If the 2 repeats, if the X repeats, it is not a function. So this one would not be a function because the X value repeats with the 2. In the last relation, we have -5, 0, and 5. The X does not repeat, so it is a function. Now, if you have a graph, if the function is already drawn for you and you don't have a list of ordered pairs to look at, we can do something called the vertical line test. A vertical line test, now vertical, remember, is up and down like this, like the y-axis is. This is horizontal, this is vertical. So a vertical line test is where you take a pencil or you take something, and I can show you my shadow, but you can't see my shadow on the smartboard here. You just like take your pencil and drag it across. So if I were going to take this line and drag it across here, would the line ever touch that function more than once? Okay, so let's just put some vertical lines up here. Here's a vertical line, it touches once. I'm just randomly putting vertical lines. Here's a vertical line, it touches once. Here's a vertical line, it touches once. Is there ever a place on there where I could draw a vertical line and it would touch twice? No, so that means the X does not repeat, so it is a function. We call that passing the vertical line test. The X does not touch twice or repeat. Now if you look at the second example, in this line right here, vertical line, you'll notice that it touches the function here and here. This is where the X is repeating. That means the X repeats, so it is not a function. It does not pass the vertical line test. In the next example, if you see this line right here, notice it touches here and here. So with one vertical line, it touches twice, and that happens all the way throughout this. This means that the X repeats, so it is not a function. The X cannot repeat. It cannot touch a vertical line twice. So you can use the vertical line test if it is a graph. So, is this a function? I cannot see a place where I could draw a vertical line. You can just randomly look throughout here. Is there any place that I could have a vertical line where it touches that blue function twice? No. The X does not repeat, so yes, it is a function. The following example, vertical line test here, it touches twice. Vertical line here, twice. We could do that several places. So the X repeats, so it is not a function. The X cannot repeat. On this one, you'll see that with one vertical line, it actually touches in 3 places. That means the X is repeating 3 times. That means it is not a function because the X cannot repeat. So in this one, notice here, looks just like the last one, touches in 3 places. That means the X is repeating 3 times. And because the X is repeating, it is not a function. The next example, there is no place that I could draw a vertical line where it would touch more than once. The x does not repeat, so it is a function. Okay, now we're going to look at what function notation looks like. In equations that you're used to seeing, we have y, the range, and then they have an equation that equals y. In function notation, we're going to replace the y with something that we call f of x. Now, this letter can be any letter. The f means for function. It could be f of x, it could be f of g, f of h. Doesn't matter what the second letter is. This means the same thing as the y, but it's telling you this will be a function, which means the x will never repeat. And then they give you an equation. And so what you're going to do here, if you look at this right here, they have an equation. All your eyes are going to see are this part. Okay? And then they tell you what to plug in to x. It looks confusing. If f of x equals 4x minus 7, then find if f of 5. That seems confusing. But what they're saying is, let me do it in a different color, that x is equal to 5. That's what they're saying with that. So all you have to do is take that 5 and plug it in to this equation. So I have 4 times 5 minus 7. Of course, we do our multiplication first. So that would be 20 minus 7, which is 13. So when you see something like this, you're looking to see what you're plugging in for x. So let's look at this again. You see the x right here, and you see the 5 right here. F of x, f of 5. That means that x equals 5, and you plug that 5 into the equation. That's going to happen. So there's that one. Okay, let's look at another example.
Good morning, OCS Middle School. One announcement today.
Okay, sorry for the interruption there. In this next one, we have an equation. Remember, the y has just been replaced with f of x, which means that this is going to be a function when you graph it. The x is never going to repeat. So if they tell you what to plug in, looky here, you notice that f of x here and f of negative 6. So that is telling you that x is equal to negative 6. So that is what you're going to plug into x right here. So that would be 4 times negative 6. And we do our multiplication first. That would be negative 24. So then you would have negative 24 minus 7. Both are negative. Same signs, add and keep, and it would be a negative 31. Now if you look at this, this is an example off of the worksheet that you're doing in my class today. Here you see f of x, but over here you see that there's two. There's f of 3 and f of negative 5. That means that we're going to work this problem twice. The first one, x is going to be equal to 3. In the second one, x is going to be equal to negative 5. And they're two separate equations, and you solve them separately. So with the first one, we have x is equal to 3. So we plugged 3 into the equation. So that is 4 times 3 minus 7. We always do our multiplication first. So 4 times 3 is 12. And then we have 12 minus 7 is 5. So f of x is 5. But what if we plug in a completely separate problem? This time, x is going to be equal to negative 5. Separate problem. So this time we're going to plug negative 5 into the equation. So first we do our multiplication of 4 times negative 5, which is a negative 20. Then we have negative 20 minus 7. Same signs, add and keep, would be a negative 27. So when you have something like this and you have two of these at the end, you might even see 3 of them. And if you have 3 of them, then you would work 3 separate equations. Okay, here's a little bit harder. Notice that we have 2 of them, so we're going to have 2 separate equations. The first time, this time instead of f of x, we have f of g. Notice there's a g here and a g here. That means that g is equal to 6. When doing that, this should have said G right here as well. But that means that we're going to plug in, the letters don't matter. That means the same thing as X. So our first one, the X is going to be equal to 6. We're going to plug it into that equation. Now, when you plug in 6 to a quadratic equation like this. I plugged in 6 for this x, and I plugged in 6 for this x. According to PEMDAS, order of operations, we always do our parentheses first. There's no operation within parentheses. Next is exponent. You have to do the exponent first. 6 squared is 6 times 6, so that is 36. Then you're going to do the multiplication, which is 30. So I did exponent, I multiplied. Now I'm going to add and subtract from left to right. And 36 plus 30 would be 66 minus 1 is 65. Now we do a whole separate problem. This time x is going to be equal to negative 4. So when we plug negative 4 into that equation, again we're going to do the exponent first. Negative 4 times negative 4 is 16. Then we're going to do the multiplication. And 5 times negative 4 is negative 20. So that gives us 16 minus 20 minus 1. Now we add and subtract in the same step from left to right. 16 plus a negative 20 is negative 4, and a negative 4 and a negative 1 is a negative 5. So this is our lesson on what is a function. A function is a relation or a group of ordered pairs where the x never repeats.